Let's take a look at two more examples of finding antiderivatives involving exponentials. Okay, so for problem number 2, we have 4x e to the negative x squared dx. All right, so I need to first go through and identify a u because it's not just e to the x dx. Okay, so when you see just a singular exponential, a singular e in your function that you're trying to integrate, you want to do u is equal to the exponent piece. Okay. And that's going to be true every time that you see just a single base e written in a problem. And that's what's going to happen on both of these. We're going to see some examples down the road where we have multiple exponentials, and then how do we deal with that? So again, a singular e in the problem means do u equals the exponent piece, okay? So now I want to find my derivative, my du. The derivative of negative x squared is negative 2x dx, okay? Now that negative 2x kind of matches up with this 4x, but to get those to be the same, I have to take this whole thing, multiply this by negative 2, multiply this by negative 2. So I'm going to have negative 2 du is equal to 4x dx. Now if you don't like the multiplying trick, your alternative is to take that negative 2, divide it to the other side, and make it negative 1/2 of du equals x dx, and then combine the 4 up here with the negative 1/2, okay? You guys have seen lots of different ways that you can manipulate these expressions to get it to match the original problem, so just keep using those same techniques you've been using all along, okay? So now when I go to rewrite this, I'm going to have my integral sign. I'm going to have negative 2 du is going to replace the 4x and the dx. So this and this both get replaced by this. So I'm going to put the negative 2 out in front and the du at the end. Again, you can put the coefficient inside if you prefer. The only thing left that I haven't replaced is this, and this is e to the u power. So now I have e to the u. And now I match the second half of that definition. Okay, so the antiderivative of this, coefficient stays put. The antiderivative of e to the u du is just e to the u plus c. Replace the u and you're done. So this is negative 2 e, u was negative x squared, plus c, and you're finished. And again, you can check your answer by doing a derivative, optional thought process, not a requirement on a test, okay? All right, so there is problem number 2. For problem number 3, again, I look at the problem and I see a single base e, so that means u should be whatever the exponent is. So the exponent here is 1 over x. So my u should be 1 over x. Okay. Now I need to find the derivative of that. It'll be easier to find the derivative of 1 over x if I make it x to the negative 1 power. So I'm going to switch this to say x to the negative 1. That way I can do the power rule and avoid the quotient rule. Okay. So now du, derivative of this, bring the exponent down. So negative 1 x, subtract 1 from the exponent to get negative 2 dx. Okay. Now, that's really the same thing as negative 1 over x squared dx. Now we've got to really think about how this works here. So I want to point out that whenever you have division, we can split it into multiplication between two separate things. But this 1 over x squared dx is basically right here. This is 1 e to the 1 over x over x squared dx, all right? So you can think of the original problem like this. I'm going to write it and then erase it, okay? You can think of it as e to the 1 over x times 1 over x squared dx, okay? Because if I were to multiply these, if I put this over 1, I'd have the same numerator and the same denominator that I have up there, okay? But seeing it written this way makes it a lot easier to make the connection between this piece and this piece. All right? The only difference now is that negative. There's no negative here, so I'm going to move the negative to the other side. All right? So this is now going to become negative du is equal to 1 over x squared dx. So when I do my rewrite, the negative in the du essentially replace this denominator x squared and this dx. And that leaves me with e to the u. Okay, so that's going to leave me with e to the u again. And we know that the antiderivative of e to the u is itself, the coefficient stays, so negative e to the u plus c, and then replace the u and you're finished. So the antiderivative here is negative e to the 1 over x plus c, okay? So there's our final answer, negative e to the 1 over x plus c. Now, one thing I want to remind you of is if you see multiple exponentials, but they can be simplified, like we talked about when we were doing derivatives, you can do those simplifications before doing any of the integral work, okay? So what I mean by that is if you saw something like this, like e to the 2x minus e to the x over e to the x. We divided this and simplified it down. If you saw this in an integral, you could still do those simplifying steps and then try to think about, well, how do I find the antiderivative from there, okay? So problems like this may still pop up, but you should know how to do that algebra to simplify before finding an antiderivative, okay? So there's example 2 and example 3.